Today, we're going to cover this chapter. I'm going to start again from the very beginning, and we're going to cover as much as we can. I hope we're going to finish the entire chapter. Let's see how it goes. So, planning for capital investments. That's the objective today. Planning for capital investments. Why do we need the capital investments? Obviously, in order to generate a long-term return, we need those capital investments. The decisions of purchasing those capital investments, those will be the one related to the capital budget decision. So in order to make a capital budget decision, we need to follow some process. First, we have to identify why do we need those budgets. First, we have to do the analyze the purchase of the capital assets itself, or replacement of the capital assets, or purchase long-term investments instrument. How we going to do this process? First, every year, at least once a year, the project proposals which requested from the department. Then we examine those proposals, see which capital budget committee using what kind of capital budget techniques. Then the corporate manager directors will sit down and determine which project is worthy of funding or which one is not, and the upper management is going to approve the capital budget or the board of directors, and we're going to do what we have to do. A few things that we have to always keep in mind. First is availability of the capital. Do we have enough capital? Second, the relationship among the proposed projects. Which one is more profitable? Which one is less profitable? Which one is to take? Which one not to take? Basic decision making. Based on what we're going to make that decisions, based on the return, based on the cover of the asset, what exactly we're going to look for. And the other thing will be level of the risk that we are willing to take. Obviously, more risky projects, more return, less risky project, less return. Let's go now with the usual cash flow information that we have to collect in order to make a decision. First, we have to see the cash that's coming in, and then we have to see the cash going out. Either we have a positive difference, either we have a negative difference, means more cash coming in or less cash coming in. So from where the cash is gonna come? First, if we have to make the capital decision, first cash is gonna come from the sale of the old asset or investment. Second, possible cash stream will be for the increase of the revenue that we get from the customers. The other possible cash stream that we may get is from the reduction of the cost, either operating, either on product. And the last one will be the salvage value of the equipment or the machine that we just purchased at the end of the useful life of the machine. Outflow are usually related to the initial investment, increase in the operating cost, repair and maintenance, and some major renovations that we have to do on the equipment. So basically, the decision that we have to make is, shall we invest in this situation or shall we not? When we have the initial investment $130,000 with the estimated useful life 10 years, salvage value, no salvage value. Annual cash flow is from the customer is going to come 200, for the operating cost 176. So net annual cash inflow is $24,000. There are two methods or two techniques that we can use. One is the pure cash payback method, and the other one is the net present value. So we're going to see how both work. Let's go with the cash payback method, the one that we saw in class. First is very simple, so that's why I'm not going to test you on this one, because it's just very simple. This cash payback method, especially the one that you're getting same amount of cash year over the year. How are we going to get the cash payback period? Simply dividing the investment divided by annual cash flow on the net cash flow that we're getting. And then we're going to see how long takes us to recover the cash flow? In this case, if the initial investment is $130,000 and we getting $24,000 constantly every year, it's gonna take us 5 years and 542 years to collect and to recover the initial investment. To collect $130,000 and to recover the initial investment. Again, how we getting it? Initial investment divided by the net cash flow that we're gonna get from the new equipment in this case. If the company have the payback period of 6 years, this project is acceptable because fall under the company policy of 6 years. Again, too simple. It's simple, but it's too simple, so not going to be examinable. The one that's going to be examinable is the one that's going to have unequal cash flows, and that will be on your final quiz. So in most instances, the net annual cash flow is not equal every year after year. So what we have to do, we have to go with the cumulative net cash flow until become equal to the cost of the investment. So we're going to get this information. So what I want you to do is, let's go to that Excel spreadsheet that I sent you. And let's work with that Excel spreadsheet. Second, I'll share my screen. Waiting to that one to open. So here we go, we have it. So what we're gonna do, we're gonna go on the worksheets on the bottom one after another. So the first one, we have the cash in. So the net cash that we're collecting is the first year we're gonna get 60,000. Second year we're gonna get 90,000. Third year we're gonna get 90,000. Fourth year we're gonna get 120,000. And the last year we're gonna get 100,000. Now the question is, at which point we are reaching $300,000? At which year? So what we can do, there are two options here. First option is start with the initial investment and start deducting until you become zero, or start with the initial cash flow and start adding it to get the cumulative. Either one works, depends what you want. Here you can do both. We can get the cumulative and we can get the remaining. So let's go with the investment 300. They're always going to stay the same amount because we're not changing the investment. The question is, how long is it going to take us to reach those $300,000? One option is, again, the remaining amount, which will be equal to, in the first year, at the end of the first year, the remaining amount that's left to recover will be 240. Next year, the remaining amount will be 150. The next year, the remaining amount will be 60. The next year, the remaining amount will be up, we become negative. So definitely it's going to take us 3 years to recover the investment. 3 years for sure. We're going to have 3 full years. Now, as you can see, in the fourth year, we're recovering the investment. The question is at which point we're recovering the investment. So what we're going to do is we're going to see how much remaining to recover. The remaining to recover is 60,000. That's how much we need to recover. But in the fourth year, the cash that we're getting, the total cash in year 4 is $400,000. So we need to recover 60,000. At the year 4, we're getting 120. So for how long we're going to recover that one? Simply, we're going to get what we need to recover divided by the total cash that we're getting. And then we're going to get the fraction of the period after the 3 full years. And that's how we're getting the 3.5 years. The other option that you can have is start accumulating. First, get the 60,000 here, then you're gonna have the 60 plus 90,000 and keep going until you reach 300. 360. So basically in year 4, we're reaching 300. So the question is, at year 3, which we know that takes definitely 3 years, how much left? Well, the left is the investment minus what we collect so far, 60,000. And again, applying the same formula, you're getting the fraction. Which way you're gonna go, it's up to you. Either you're gonna go with the remaining, either you're gonna go with the cumulative. It doesn't matter as long as you realize that it takes you 3 full years and fraction of the year to get it. Okay, let's keep going with the slides. That will be rationality under the PowerPoint slides, how they're getting the 3 years and how they get the fraction of the part of the 4 years when we recover the investment. Again, this one will be tested on the final quiz. Not only that, obviously, I need you to give me the pros and cons on the cash payback method. What's the benefits to have it? What's the negative to have it? Obviously, benefits to have it is you can easily see it, easily perceptive. It's easy to understand. It must be the most crucial factor for the capital budget decisions, since you want to see how much, how long it's going to take you to recover your cash if you have a weak cash position. The drawbacks is doesn't consider time value of the money. Should not be the only one on basis for the decisions because ignores the expected cash after the cash payback period. We already answered this question. The answer was to identify the time value required to initial capital. And let's do this one together. In order to do that, let's move back to the Excel spreadsheet. And on the Excel spreadsheet, if you go now, we're gonna work with the second worksheet. We have already the information for us available. The only thing that I can do right now is to copy this and move it there. That will be something new that you also can do. And that will be the new element of the calculation. So we can do it both ways, either with cumulative, either with remaining. I'm going to unhighlight those one, and I'm going to add year 6. That's the only thing that I'm going to do. And we're going to start with the initial investment. For us, in this case, the initial investment, as you can see, is $100,000. So the question is, how long is going to take us to recover those $100,000? First year, and the first year we're collecting, expected to generate net inflow. So now in this case, we have expected useful life 6 years, at which time can be sold for 10,000. Since the $10,000 at the very end of the life of the machine, that 10,000 will be ignored. And let's go with the expected cash that the machine is going to generate. 21,000 in first 2 years. So we're getting 21 in the first year and 21 in the second year. Then we're going to get 25 in the third year. Then we're going to get 30,000 in the fourth year. And the last thing is the last 2 years, we're going to get 26 and 26,000. So in total, how much cash we're going to get? If we have to calculate how much cash we're going to get in total, we're going to get exactly $149,000 cash. Obviously, we're getting more cash than the initial investment. The question is, when we recover the investment, how long it's going to take us? So as we were looking at the remaining, at the end of the first year, we still have to recover 79. At the end of the second year, we still have to recover 58. At the end of the third year, we still have to recover 33. At the end of the fourth year, we still have to recover 3,000. So definitely gonna take us 4 years to recover the investment. 4 years, that's for sure. So that's the first number we have here, 4 years. Now what's left? Left 3,000. But those 3,000, we're gonna recover it in the year 5, correct? So 4 years for sure. The next we're gonna recover to year 5. But the 3,000 recover, we have to divide it by 26,000 and we're gonna see how much is gonna be left. So in this case, it's left 1.2 and that becomes our fraction. So in this case, it's gonna take us 4 and 4.12 years to recover our initial investment. If we want to do it cumulative, the first year is 21, second is 42. The third year, we cumulative, we're gonna generate 67. The fourth year, we're gonna generate 97. So how much left is here? We left to recover 3,000. How much left to recover in the other case? Also 3,000. And the question is, what's the time that, or fraction of the time that we need to recover those one? 3 divided by the amount that we're getting for the last year, it's going to give you the fraction that's added to the years, give you the answer, 4.12 years. Again, the calculation is the simple part. More important will be you to explain to me what's the pros and cons of the simple cash payback method with the uneven cash flows. Time value of the money. Time value of the money, as we said, time value of the money comes from the fact that dollar today worth more than dollar tomorrow. So basically, if we receive $10,000 tomorrow, today those $10,000 will be less. We're going to use discounted cash flow method. Discounted cash flow method will be, we're going to decrease the value of the money by percentage, which percentage will be discounted rate. And we're going to use the 2 discounted cash flow methods, net present value or internal rate of return. They're very kind of connected to each other. So once we want to explain the one, we're going to see what's the effect of the other one. Net present value is generally recognized as the best conceptual approach to make a capital decision. So what's the best approach? Net present value. So what's the drawbacks? So about what will be the benefits of having the net present value method? Obviously, you have to pay attention now because that will be tested as well. Under the net present value method, we're going to discount the cash. And then we're going to compare with the initial capital investment that we're making. Interest rate that we're going to use for discounting will be the required rate of return or the minimum required rate of return of the company, the money that the company wants to generate, the minimum return that the company wants. So in that case, since we have 2 streams, one is cash coming in and the other stream is cash coming out at the very beginning, we're going to compare and see what's the net present value. And if the net present value is 0, that means simply that project reach the minimum required rate of return, which is used as a discounted percentage to discount the future cash flow. If we generate a positive net present value, simply means that the project will earn more than the required rate of return, or the rate that we're using as a discounting the future cash flow. And if the project end up with a negative net present value, that means the project will not reach or gonna get less return than the minimum required rate of return or the discounted rate that we use for our calculation. Again, that's the decision tree. However, as I explained in the class, don't blindly follow the decision tree. Make your judgment. Calculate the net present value and then reach the required rate of return internal rate of return for the project, which we're going to see today, and then make your decision. Net present value, at least, again, is a guidance for you to make a decision, but you still have to use other things. If you blindly follow the net present value, even if you're comparing the project with a different discount rate, most likely you're going to make a mistake. So with the net present value, what's the cash flow that will take? Those will be two patterns. One will be the series of equal payments, which is called annuity. We can have an ordinary annuity or annuity due. Ordinary annuity is when the cash flow happens at the end of the period. And the annuity due is when the cash flow happens at the beginning of the period. That would be example for the rent payment. The other one will be example of the revenue when we're getting the revenue. Unequal cash flows is that a single lump sum. That will be the salvage value that we're going to get at the end of the life of the project, or that will be payments that we're going to get through every year at the end of the year, but they're not equal to each other. So the cash flow pattern determines how we're going to calculate the net present value. One option is if we have each payment at the end of the year is equal, then we're going to go with one calculation that then we're going to use usually we're going to use the ordinary annuity, assuming that the cash always happen at the end of the period. Now, what we need to know the amount of each payment, number of the payment, minimum rate of return, or which will become a discounting rate that we're going to use to calculate the net present value. And the other option and the last thing that we need is either a financial calculator, the one that you had in your hands during the quiz, or Excel spreadsheet. The table is not going to be using the table, but I'm going to show you how that works on the table. Anyway, so what we need, again, we need the amount of each payment. So in this case, each payment is $1,400. How many times we're going to get the number of those payments? 9 times. What's the minimum rate of return or discount that we're going to use a discounted rate? Well, 6%. So if you use the table, you're getting the 6%, and you're scrolling down, going down until you reach 9 periods. Once you reach the 9 periods, you're going to get the number that you have to use to discount the cash that you're going to receive. So in this case will be 1,400 times this number that you're getting here, and you're going to get the value of the 1,400, which you're going to receive 9 times at the end of each year, discounted at 6% value today. That's what we're calculating. So now let's stay with our project, which initial investment, if you remember, was $130,000, and we're getting the annual cash flow $24,000 each year at the end of the year, and we're going to discount it as 12%. So in order to do that, we're going to move to the Excel spreadsheet, and we're going to open the worksheet number 3, and we're going to see our question sitting here. So we have initial investment. So how are we going to enter the information? Initial investment, the outflow is the outflow that we have to pay today. That's $130,000. We're paying those one today. Then we're going to get annual payment every year, year after year after year after year, which is the consistent net annual cash inflow of $24,000. That will be our payments every year that we get. And we're going to get those payments over 10 years. So in total, we're going to get $240,000. $240,000 is definitely more than $130,000 if we ignore time value of the money. Now let's see if we want to get a return 12% over on the 130,000 year after year over the 10 years with this annual cash flow, are we getting the 12% or not? So the 12% is our discount rate. Salvage value, there's no salvage value because as we said in the question, and we cannot sell it at the end of the 10th year, so that will be zero. How are we going to calculate the present value? Well, very simple. We have Excel spreadsheet which can help us. Now for the Mac people, I'm not sure if they're Mac people that will be a little bit different when you enter the formula. But all the PC users, what you have to do, go to formulas, go to financials, scroll down until you see PV, which means present value. And you can see the explanation here returns the present value of the investment. The total amount that series of future payment is worth now. Let's stay on the PV and we start entering the information. First, gonna ask you for rate. Rate is the discounted rate or the internal rate of return or required rate of return. In this case is 12% and we will leave it there. Second, number of the periods. How many times we're gonna get those money? 10 times. And we enter period. Payment. Payment is 24,000. And with payment, in order to get the positive amount, we're gonna enter it as a negative amount. Is there any future that we're gonna get at the end of the period? No, there's nothing there. So we're gonna enter here 0. And the last time that I ask you, what kind of type of calculation is this? When we're gonna get in other words, when we're gonna get the payment? At the beginning of the period or at the end of the period? And if you use it as the beginning of the period, you have to enter here 1. If we getting the payments at the end of the period, we can enter 0 or do nothing. Let's decide to do nothing. Because that means if we consider the end of the period. We're doing the calculation with our discount rate, and we're getting that present value of 10 payments of 24,000 over the 10 years, discounted at 12%, today worth 135,605. So when we're deducting the initial investment, $130,000, so our net present value will be, so let's do the cash out as a negative in this case. So we're going to see the present value of this adventure is positive. What that means to us simply again means that we're reaching the 12% return and we're getting more than 12%. Now, how much more we're going to get? We're going to come back to this later when we have to calculate the internal rate of return. But definitely we're getting the 12%. So from the slides, what we're going to see is exactly the same. On the slides, they're using this number here, which is 12% over the 10 periods, and they come up with the exactly same amount, and they come up with the exactly same amount of the net present value, which is positive. That means this project is acceptable because meeting the 12% return that is required by the company, and the proof for that is the net present value is positive. So the net present value in this case, it doesn't mean anything. It means only that the project's gonna reach 12% return. This is not the cash, extra cash that we're gonna get over the 12%. Again, it's just a number, nothing more, nothing less. What's gonna happen if we have unequal cash flows? Well, for the unequal cash flow, then we have to think about those cash flows that cash flow will be at the end of each period. So we have to discount each of those cash flows and bring them the present value today. And then we're going to calculate all the present values over the periods that we have, and we're going to see how much is the total present value, and then we're going to get the net present value. Let's see our example here. Here we're going to have that we have 3 payments over the 3 years. First year, at the end of the first year, we're going to get 6,500, and then of the second year, we're going to get 4,000. At the end of the third year, we're going to get 3,800. What's the present value of those payments today if we require 6% return on our money? That's what we have to find out. In order to do that, again, we're going to use the Excel spreadsheet, and we're going to go to the worksheet that says Q4. Actually, that's not the one that we're looking for. That's a repetition of the previous question. Let's go to Q5, and on Q5, we're going to see what's waiting for us. So how much, in this case, we don't know how much we have to invest, so that will be out of the picture in this case. We're only getting the cash inflow. First year, we're going to collect 6,500 at the end of the first year. Second year, we're going to calculate, we're going to get 4,000 at the end of the second year. And the third year, we're going to get 3,800 at the end of the third year. In total, we're going to get $14,300. The question is, how much they worth today if we require 6% return? So let's get rid of this first one. So now our annual payment, there will be no annual payment. Why? Because those payments, they don't repeat itself year after year. So what we're going to get, we're going to get the future value of the payment at the end of the year. So the first year, so let's go at the end of the first year, we're going to get $6,500. But since we're getting at the end of the year, how much time passed, that will be 1 year past. We want 6% return. So that 6% is going to stay for all the calculation. Second, at the end of the second year, we're going to collect 4,000. So what's the distance from today until the second year? End of the second year, 2 periods pass. And the third year, at the end of the third year, we're going to get 3,800. But that will be 3 years from now. So first we have to calculate the first present value, then the second, then the third one. And the total is going to give us the present value. So let's go with the first one. Again, we're going to use the financial. We're going to scroll down to the present value. And we're going to have for rate is the discount rate. Number of the periods, 1. Payments, in this case, will be 0. Future value, in this case, will be negative 6,500. And the value of those 6,500, if we receive it at the end of the year with 6% return, the required return, the value is $6,132. Now let's see what's the value of the $4,000 discounted at 6%, received 2 years from now, the value today. That will be again financial. We're going to use the present value again. Rate is 6%, number of the periods now is 2, payment is 0, and future value is negative 4,000. Those 4,000 after 2 years worth today 3,559.99. And the last present value that we have to calculate of 3,800 received 3 years from now, discounted at 6%. Again, we're using the financial present value. We're getting the rate is 6%. Periods now is 3, payment is 0. And the future value in this case is 3,800. So those 3,800, 3 years from now, worth today is 3,119.55. So in total, the present value of this $14,300 is not $14,300. It's gonna be this one plus this one and plus that one. So it's gonna be in total $12,882.61. And that's the present value of those 14,000. So now let's play it a little bit so you can see what's happening here. Let's make all those interest rates to be reading from each other. So once I change one, everything to be changed. So let's say the interest rate is 0. If the interest is 0, then that means there is no inflation. We don't want any return, nothing. That means whatever we're gonna get, it will be exactly equal to the total amount of the money. Unfortunately, that's not the case. We want something. Why? Because time value of the money and the considerations of inflation, which most of you mentioned in the class. So if we want to cover only the inflation, which we saw, or you can find that the Statistic Canada probably is around 2% only, the value of those 14,300 today is 13,798. So what we can see is higher percent we're using, present value getting low. Can you see it? If I'm increasing the percentage, the present value getting low. Make sense?
Yes, it does.
When I'm reducing the percentage, the present value start increasing. So let's go with the 6% and leave it at 6%. So now let's go here and see this calculation. Let's play a little bit with this calculation to see what we can get. So again, the $1,330,000 we're gonna pay today, but we're gonna get annual payment of $24,000 over 10 years with 12% discount rate with zero future value, no salvage value. Again, present value of those one are equal to rate is 12%, period is 10, payment is negative 24,000, and the future value is 0. So the net present value become positive. Now, what's going to happen if I increase the interest rate or discounted rate? What's going to happen with my net present value? What do you think?
Your net present value will decrease.
Will decrease. Let's see if that's true. If we put here 13, net present value decrease. If I go further, what's going to happen? It's going to become negative. Now, what the negative means? Negative simply means that with this project, we cannot reach 14% return. You can reach anything else below 14, but not 14. So if you want minimum 14%, this is not the project that you have to invest in. If you want 15%, that definitely is not the project that you want to invest in. But if you want 13%, should I invest now?
Yes.
Yes. So you can see if you're decreasing your expectations, if I want only 5%, oh, you definitely should invest. This one definitely give you at least minimum 5% and more. So the question is, how much exactly this one gives me? And how we're going to find out when we're calculating the internal rate of return. Later on, we're going to focus on that one, how to calculate internal rate of return. Because the internal rate of return is going to give us how much actually, or what's the amount that brings the net present value to 0. Because remember, when the net present value is 0, that means present value of all the calculation is equal to the initial investment. That's the only way you can get it to 0. So basically, what you're chasing is the present value of the future cash to be equal to the exactly same amount of the cash that you're spending today. Okay, let's go back to the slides. So they're using these fractions and calculating. Let's do this question now. In this question, which is related to our original question when we initial investment $130,000. Now, over the 10 years, we're not getting $24,000. We're getting different amounts. In total, we're still getting $240,000. Don't get it wrong. We're still getting $240,000, but we're getting different amounts every single period. Now, the question is, what's the present value of this $240,000 which I received on unequal amount over the years with six, I believe the 6% was the discounted rate. So what we're going to do now, we're going to move to the next question, next worksheet, which will be the worksheet number 6. And we're going to start working with the formulas here. So how are we going to use the formula? You already have the formulas for you. I'm going to do some tricks here in order to keep it fair to you. So first I'm going to delete everything and then I'm going to plug it again. Okay. So you can see how everything, what's the logic here. First, in the very first scenario, if you remember, in the very first scenario, our initial investment was $130,000. We're getting $24,000 payments every year over the 10 years. In total, we're getting $240,000. Our required rate of return or the discounted rate that we're using is 12%. With that, we're definitely reaching the 12%. Net present value is positive. So that means we're reaching the 12%. Let's go the same scenario, but this time we're going to get uneven cash flows every single year. So what do we have to do? Now, at this point, I cannot use these annual payments anymore because they're not equal. So we have to do it on the kind of hard way. So what I'm going to do is I'm going to copy this and I'm going to move it here and I'm going to start plugging the numbers. So what I'm going to have is actually, I can get rid of this, make it closer to you so you can see it. So what I'm going to have is, I'm going to have cash that's coming first here, cash that's coming second year, and cash that's coming in third year. The first year, since I don't have annual payments, I'm not getting constant amount year after year. I'm going to use the last one, which is the future value of the payment that I'm going to get at the end of the year. And the first year, I'm going to get $34,000. The second year, I'm going to get $30,000. And the third year, I'm going to get $27,000. My discounted rate is the rate that I want is 12%. And that's still 12%. And that's still 12%. So with this simple calculation, what I'm finding is how much worth $34,000 receive at the end of the year a 12% return today. Then I'm finding how much is $30,000 that they receive at the end of the second year discounted at 12% today. Then I'm trying to find out how much is the $27,000 receive at the end of the third year at the 12% return today. So that's 3 years now. Let's make it 6. So what we have to do, I'm gonna copy this and paste it. You don't have to do anything because you already have it. And that's your year 5. That's your year. Sorry, that's year 4. That's my year 5. And that's my year 6. So I have here 4, 5, and 6. The only thing that I have to change is the values. In the fifth year, I'm getting 24,000. On the fifth year, I'm getting, the fourth year, I'm getting 25,000, not 24. So this year, I'm getting 25,000. The fifth year, I'm getting 24,000. And in the sixth year, I'm getting 22,000. So as you can see, the value keep going down, keep going down, keep going down. First, because the amount going down, and second, that because we're getting more distant from today. So let's keep going. I'm gonna copy and paste this one again, so you can see what's happened. Now I have to plug for the year 7, 8, and 9. 7, year 8, and year 9. And I'm going to put the numbers here. On the year 7, I'm getting 21,000. At year 8, I'm getting 20,000. And at year 9, I'm getting 19,000. And there's one more year left for me. So I'm going to get this one more time, and I'm done with this. So that will be, now I have to change here the periods. That will be 7, that will be 8, and that will be 9. And the last one that left for me, that will be 10 years from now. And the payment that I'm going to get 10 years from now is only $18,000. So now the question is, all those present value that are calculated year after year after year after year, how much is the total? So my total here will be equal to this amount plus 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 that amount. So in total, my present value is 144,000. Again, initial investment 130. So I'm getting net present value 14,000. So if you get $24,000 each year with no changing, your net present value is only 5,605. But if you get it as an uneven amount, starting with the higher in the beginning and lower at the end, you're gonna get net present value, which is 14,000. So what that means? That means your return, it will be way higher than 12%. Right here, you're reaching 12%, and also here reaching 12%. 12% is in guarantee. But the question is, what's the actual return? And that's what we're gonna get when we calculating the internal rate of return. That's what we're gonna use when we're gonna use the formula for the internal rate of return. So the other thing that I want you to pay attention is, if you can see all these calculations, the other thing that we getting this internal rate of return, present value and net present value of higher. It's only because this is the order that we get in the payments. Now, if we change the amounts here, if we're getting less in the cash in the beginning and higher cash in the end, that's going to change. How it's going to change? You have to play with the numbers. So, but let's see one comparison, just quickly comparison. I believe we're good with the time, so let me do one twist here. So we have our original data, and I'm gonna copy this one, and I'm gonna paste it here for comparison purposes only. Okay. only for comparison purposes. This is what if we getting those payments in this order. Let's flip the order. How can I flip the order? Very simple. I can easily go here, sort, and I'm gonna go with the smallest to largest. And I'm gonna stay with the current selection. So what's gonna happen if, no, this one doesn't accept it, but let's see, let's try again. Let's go with the custom, continue with this different, and let's use my heading. Let's forget about the headings. Okay, so now 18, I'm getting the opposite order. Smallest one in the beginning, the largest one at the end. Obviously, this calculation is not going to work anymore, but if you want to work it, you have to make it this one time, this percentage, then you're going to work. Right? If you want to add this calculation in the part. So if we do this, what's going to happen now? Can you see? What's happened with my net present value?
It's decreased.
It decreased. Why?
My assumption is the investment, the larger the investment upfront.
The cash flow that we're getting.
Yeah.
It's the timing of the money that we're getting. If we're getting higher amount in the further distant future, the present value is way less. So watch this. If I have $34,000, which I'm receiving 10 years from now, with 12% expectations, worth 10,000, watch this. And that will gonna worth 10,096. Let's get those numbers just in case, and let's make comparison now. And I'm gonna paste those one as a values. So let's do the other calculation here, the other flip. Let's flip it back to the original data. Make sense? I'm gonna flip it
Yes.
back to the largest to smallest. The only thing is, now when I flip it to largest to smallest, now what I have to do is I'm gonna get this one. And what I'm gonna do is largest to smallest only this one. No, I don't want to do that. Largest to smallest, I'm gonna stay with the current. And now, watch this. The $10,000, the $34,000 received at the end of the first year, it worth $30,000. But if I receive them 10 years from now, it was only $10,000, $11,000. Make sense?
Yes, it does.
So for that reason, if we receive the highest payment in the beginning and the lowest payment at the end, we have a higher net present value. But again, if we go back to the previous case scenario, our net present value now is negative. So basically, with this way receiving cash, we're not gonna reach the 12%. So in that case, even though we're getting the same amount, we shouldn't be investing in this project. So you can see how one small twist can make a huge change. Again, the first scenario is when we get $24,000 equal every year after year over 10 years. The second scenario, this scenario is when we get the beginning highest cash in the beginning, lowest cash at the end. And the last scenario is when we're getting the lowest cash at the beginning, highest cash at the end. That's how sensitive this calculation is. So let's go back to our slides. And continue with the slides. Obviously, in this case, with those cash payments in this order, this investment is acceptable because guarantee you the 12% return. Let's do this question now. In order to do this question, let's go back to the Excel spreadsheet. And let's use the question 7 slides. Worksheet for question 7. So what do you have to do here? We're going to have to consider purchase of the new machine at the cost of how much we have to pay today?
100,000.
$100,000. That's 10,000. Let's put one more zero. $100,000. We're expecting useful life 6 years. So how many periods we have?
6.
6. And can be sold at 8,000. Are we going to get salvage value?
Yes, we will.
How much? 8,000.
8,000.
Right? At the end of the 6th year. Make sense?
Yes.
That will be something that we're going to get in the future, 6 years from now. The next thing that what we also going to get, this machine is going to generate net cash inflow every each of the 6 years. So that will be our annual payment year after year after year after year of 21,500. What's the discount rate that we're using?
5%.
5%. So now the question is, whatever we get here, is it going to be enough to cover this amount? So we know our cash outflow is definitely negative, 100,000. We have to pay those $100,000. Whatever. Now the question is, this amount of the present value, is it going to be higher than 100,000 or less? If it's exactly $100,000, that means there's no inflation and no return. Correct?
Correct.
Okay, let's go now. Formulas. Financial, future value. Rate, we have it, 5%. Number of the years,
6.
6. Payments,
21,500.
enter it as a negative so you can get the positive result. Why doesn't ask me here? Oh, I'm on the wrong calculation, sorry. I'm not on PV, I'm on the FV. I should be on the PV here. So let's go again, rate, 5%. 6 period payment, 21,500, that will be negative. And then we're going to have the future value, which is also negative of $8,000. So how much this is going to worth today? 115,097. So what that means? That means that we're reaching the 5% return. Make sense?
Yes.
Shall we invest here or not?
Definitely invest.
Invest. Why? Because we're reaching 5%. Correct? Okay,
Correct.
great. So let's keep going with the slides. In this case, that's the correct answer. How are we going to choose this discount rate? Well, there's a different methods to choose that discount rate. Usually, we're going to look at what the owners want. We can come up with the different ideas. Discount rate of the company can be the cost of the capital. If we go with the cost of capital, then we have to calculate the weighted average cost of the capital, which is the weighted average cost of the borrowing, plus the weighted average cost of the investing, and we're going to get some percentage. That's crazy calculation. I'm going to leave it for the finance people to explain that one to you. Now, if the project, obviously, if you want high risk, you have to increase the discount rate. If it's too risky, high discount rate. How discount rate can be presented in different terms. It can be called hurdle rate, it can be required rate of return rate, it can be cutoff rate. all those means one thing, discount rate. Which are the consideration for the discount rate? As we saw in the formula, every time when the discount rate increase, net present value is gonna go down. If the discount rate increase, that means we increasing the risk of the project. And we also have to consider this, what's going to happen if something else happens. Assumptions here are the simple assumptions are that all the cash flow came at the end of the year. All the cash flow received during the period are immediately reinvested, and all the cash flow can be predicted with certainty. Also, the projected results are estimated that are based on the forecast, which will be believed to be the most accurate and is going to happen. And how we're going to deal with the uncertainty is when we present this sensitivity analysis. On the sensitivity analysis, we're going to use the several outcomes for the estimates to get the sense of the how risk averse you are and what's the potential impact in our project. The same thing that we did. What if we change the cash going different direction? What's going to happen? So let's see how you're going to respond to this question. What's going to happen if the discount rate increase? Let me copy this one. And let's go to the Excel spreadsheet. And let's play with the scenarios. Let's go with our original scenario, this one. Can you guys see it?
Yes.
Yes.
Okay. So I'm gonna move here and I'm gonna have this thing. And now I have extra Excel sheet. And I'm gonna put this question. So what we have to compare? I'm gonna delete this. Actually, no, I'm gonna leave it. I'm gonna get this calculation here. Copy it and I'm gonna paste it right here. Not there, more likely here. And I'm gonna increase those so you can see everything. Can you guys see the information?
Yes, we can.
Okay, excellent. So let's go with the first scenario. What will be the impact? Let's make it this smaller so I can see it and you can see it. So we're chasing this comparison versus this comparison. Make sense? We're comparing those two only. Let's get rid of this because this one is now destruction. What's going to happen if discount rate increase from 12 going to 14? First one, there is no impact on the present value. Is that true? We increase the interest rate. Is that true? Did the net present value change?
Yes, it did.
Yes, it is. So first one is gone. Second one, internal rate of return requirement will increase. Internal rate requirement will increase. Well, internal rate of the discount rate increases, but are we reaching the internal the rate that we're gonna need to make this one positive, is it going up or going down?
It's
So
it's
if the
going,
disc is
yeah,
going up, so
yeah,
but
it's going up.
but remember the discount rate increasing. Is it possible the internal rate to increase?
Maybe I don't understand the question. Is it more that if the internal rate increases, therefore our present value decreases?
Well, if
And
watch this. If the discount rate increases, the net present value become negative. That means the
yes,
internal rate of return going down,
that's correct.
right? But this question says it's going to increase. Is it increasing? No, it's
No,
decreasing.
it's
So
decreasing.
this you're eliminating the D.
Okay.
Present value, the future cash flow will increase.
No,
No, the present value actually going down, right? When we increase the
that's correct.
discount rate, the present value go down. So which one is the logical?
B.
The annual
So
cash inflow will need to increase in order to retain the same net present value. How much is the net present value here? 5,000. So what I have to do, I have to bring that one to 5,000. What do I have to do? I have to increase my annual payment. Where it's going to be? Let's see, if I put 25, it's going to be 4,000. So I need more than, if I go 26, you see where we are? We are on 26. So basically what I have to do, I have to increase the annual cash flow in order to retain the same net present value.
makes sense.
Make sense? Okay.
Yes.
So that will be the correct answer here. Now let's go with the challenges when we have intangible benefits. If we have intangible benefits which cannot be calculated by numbers, then we have to calculate the net present value. Usually when we're doing this, we're ignoring intangible benefits. So one of the drawback of the net present value method is ignoring the intangible benefits. So when the question asks you what's the negative on the net present value, now you know what you can answer. So then if the net present value become negative, we can ask what's the intangible benefits. Sometimes you're looking, it's okay, so I'm not getting 12%, I'm getting a little bit less than 12%, but I like the color. I want to go with the color. So the project rough conservative estimates of the value of the intangible benefits, we have to get those one in order to get the right decision. So let's go with this one and see what we're going to do in this case. We have this company which consider purchase of the soldering electrical components, which cost $200,000. Net cash flow is estimated to be 30,000 per year and useful life 10 years and discounted at 12%. Let's move to Excel spreadsheet and find which worksheet is going to help us with that. That probably is going to be worksheet number 8. Let's go with 8. So this company is considering the following. They want to, how much is the initial cost?
200,000.
200,000, which become our outlay. That will be equal to negative that one. So what we're going to get? Payment, how much we're going to get?
30,000 per
30,000
year.
per year. How many years?
10 years.
10 years. What's our rate of return that we want?
12%.
12%. Any residual value?
No.
No. So let's do the calculation. Financial, going to the present value, rate is 12%, number of period 10, payment is negative 30,000, future value is negative 0. So we're getting 169,506. Is that enough to cover our initial investment?
No.
No. Oops. Not that one. Should be plus here. We are down. So basically, we're not going to reach 12%. That's the only thing that net present value shows you. It doesn't show you that you're going to be losing $30,000. Don't get me correct. Don't get me incorrect here. The net present value doesn't show how much you're going to lose and how much you're going to gain. Nothing. Nothing like that. It's just a number which tells you, are you going to reach 12% or not? In this case, we're not reaching 12%. Clearly. Now, let's do some twist here in the questions. The slide's going to suggest some twist. What will be the twist? So we technically, at this point, net present value is negative. What's going to happen? Now, they're expecting to improve the overall quality of the products. And because of the improvement of the quality of the products, they expect to, the warranty cost, they expect to go down. Also, they expect to increase the sales. Now, the intangible benefits in this case is improve the quality. So the question is, if we incorporate this in our question, where will be the net present value? And once we do this, what we have to do is the increase in sales and decrease in the cash on the warranty cost, is it going to be enough to overcome the negative 30,000 on the calculation? So the sales increase is 10,000 per year. Warranty cost decrease is 5,000 per year. Let's go to our calculation here and see what we're going to have. So now we need the initial information, which is the $30,000 increase here comes because we have annual cash inflow 50,000, annual cash flow 20,000. Now, having those in mind, once we incorporate the changes, where we gonna be? Our investment will be the same, correct? No change in the investment. How much will be now our annual cash inflow? Let's increase
That's
it with
increased.
10,000, right?
Yes.
How much is gonna be now?
60.
60,000. How much will be our outflow? Used to be 20, now we're gonna decrease it with 5.
That's correct.
So it's gonna be only 15, right? So here we're gonna get 60 minus 15. We're gonna get 45. So means that our annual payment is gonna increase with $15,000. The question is where we are now. Again, we still have to spend $200,000, but the annual payments that we're gonna get now are 45,000. We're still gonna be over 10 years, and we still want 12%. Oops, that's percentage only. Salvage value, no salvage value in this case. So I'm gonna copy and paste this one. I'm actually gonna get those two. I'm gonna copy and paste them. They should naturally flow in the same format. So where we are now?
Now we have a profit.
Now, hold on a second. Before you say profit, is it profit? Remember, we get positive net present value. That's it.
Yeah, we did. However,
Right.
we've increased the annual payments, so
We increase the annual payments, but what that means now the rate that we're gonna achieve return is gonna be higher than 12%. That's all that means. Make sense?
Yeah, that does.
That's all that means. Here we cannot reach 12%. Here we're reaching 12%. Even we're getting higher than 12%.
So
Yes?
in working all of this out, is the core idea that we're trying to figure out is whether to keep the percentage at, or the percentage that we were given, the discount rate, whether that is sufficient enough, or we
Yes,
then need to increase our input.
yes, that's what we're trying to achieve here. So with the new information, we're achieving positive net present value. That means in this case, the 12% is achieved, even we're getting more. So tell me what will be the correct answer here?
I think it's A.
Which one is not intangible? Think again and let me know. Which one of those is not intangible benefit? Product quality. Can you see it?
Yes, you can.
But is it tangible or intangible benefit?
Tangible?
It's more like intangible benefit. It's a
Yes.
quality. It's a quality, right? Employee loyalty. Can you measure it?
Yes.
Yes, but is it tangible benefits or intangible benefits?
Tangible.
More like intangible. Intangible, yes, intangible benefits, yes, intangible benefit, or quality, intangible benefits, including all except which one? Product safety, is that tangible or intangible?
Intangible.
Intangible. Salvage value.
Tangible, because you
Tangible.
have the actual
Yes, that will be tangible. So what will be the correct answer here?
C.
C. Make sense?
Yes.
Let's go now the profitability index. So now the profitability index is interesting idea because sometimes the company has money and has projects which generating the positive net present value. However, we don't have money to spend in all those projects. So we have to choose only one which is more beneficial for our company. And since we know that net present value, it doesn't measure cash or anything like that, the question is, which project would you choose? The project with the highest net present value or the project with the lowest net present value? Which one? Since again, don't forget, net present value doesn't measure cash or profit. So choosing the project with the highest net present value, it might not be always the best decision. Because if you're using for lower discount rate for one of the project and higher discount rate for the other project, the project with the lower discount rate can give you ginormous net present value, and that is still going to be less return than the project with the higher discount rate. Keep that in mind. Now, what will be the question? How are we going to make that choice? Well, we're going to add a new element here will be profitability index. Profitability index will be, we're going to see how it's calculated, but first we see what's the logic here. If the profitability index is more than 1, that creates value for the company. So it should be accepted. If the profitability index is less than 1, it doesn't create value for the company, should be ignored. And if the project profit index is equal to 1 between two projects, then both projects are equally important for the company. How are we going to calculate that profitability index? Very simple. We're going to get the present value of the net cash flows, and we're going to divide it by the initial investment. And that's going to give us the profitability index. Again, present value of the net cash flow divided by the initial investment. This is our example here. Let's go to the Excel spreadsheet again. And we have this question right here. So the project A, we have initial investment $40,000. On project B, we have initial investment $90,000. Annual cash inflow is 10%. Annual cash inflow on the second one is 90%. 19,000, sorry, 90%, 10,000, 19,000. Salvage value 5,000 versus 10,000. Looks like from the project B, we're going to get more cash. Is that more profitable for us? Let's check the profitability index. We're going to get the present value of the project A. We're going to get the present value of project B. Then simply what we're going to do, present value divided by initial investment, and we're going to get the number. And we're going to choose the project with the highest number. That's how simple it is. Which one has the highest number? A or B?
A.
A. So we're going with A. And we're going to will be more profitable with project A rather than project B. Means that the return that we're going to get from project A will be way higher than the project B. The question now is, how much is the net present value? If we have to, that's a profitability index, correct? Let's
Right.
compare the net present value. What will be the net present value? That will be simply the present value minus initial investment. In the first case, we have 18,000. The second case, we don't know how much we have. We're going to get this one minus the 90,000. Which one have the highest net present value?
B.
B. Are we going with the highest present value?
Yes, in this case.
No, 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 no. Based on the profitability index, we're not changing based on the profitability index. Are we going with are we choosing the project with the highest net present value?
So if it's based on profitability index, then it is A.
So that's the thing. We always based our decision on the profitability index. We never base our decision on the net present value.
Okay. So if we had a question, we'd have to work out the profitability index
So if the question,
always.
so look at this. First, the type of questions that you're going to get. If you have only one project, calculate the net present value. Now, if you have two projects and the manager says, I can choose only one of them, I cannot go with both. Make sense? Then you're going to choose the one that give you the highest profitability index.
Okay. It does make sense.
Make sense?
Yes.
So if you have $130,000 to invest, yeah, you invest in both projects. But if you have money only to invest in one of those, go with the higher profitability index. Right? It's all about the resources. Do you have where are on the resources? If you have limited resources, then choose the higher profitability. Again, as you can see, the net present value on project B is higher than the net present value of project A, but we're not going with project B, we're going with project A. Because that's not the best decision. So basically, profitability index exceed in project A than project B. So the project A is always going to be more desirable. So again, if you have the project with the positive net present value, check which one give you the higher profitability, go with that one. Be efficient rather than hardworking. Yeah, and that will be the moral from this thing. Profitability index example is in the previous slide. If the projects are not mutually exclusive, and if you have unlimited resources, then go with the both one, since you have the net present value positive. But if you have limited resources and you have to choose only one, go with the higher profitability index. So let's see this question. This is what we have to, this is the information. And we can choose only 2 projects. Nothing more, nothing less. 2 projects only. The question is which one we're going to choose. Let's go with the Excel spreadsheet. And question 10. On question 10, we're going to have this one here. So let's go with the, let's add a new column here and let's go with the net present value here. First project give you $500,000 investment. Second project, $800,000 investment. Third one, 725. Last one, 625. What's the present value of the net cash flows on the first one? It's going to be present value of the cash inflow minus the outflow. Make sense?
Yes.
Is that what we're getting? No, that's not what I'm getting. So I have to put here plus. So from the first one, I'm getting net present value that much. On the second one, I'm getting that much. On the third one, I'm getting that much. And the last one, I'm getting that much. Simple calculation. Again, cash inflow minus cash outflow. So what's the net present value here? Present value of the cash flow minus initial investment, right? Am I getting positive present value here?
Yes.
Yes. Am I getting positive present value here?
Yes.
Am I getting positive present value here?
Yes.
And the last one? Yes.
Also.
So all the project give me positive net present value. So if I don't have a limit resource and the money are my limit resource, I should invest in all the 3 projects. Because all the projects going to give me the return that I want. But which one are the more profitable? Now we're getting with the present value divided by investment.
Initial investment.
So the first one will give you 132. Second one is going to give you 175. Next one is going to 122. And the last one is going to be 171. So in this case, we're choosing only, if we have to choose 2, I'm choosing B and D. And I'm going to forget about A and C. Make sense?
Yes.
Okay, and the correct answer here will be C, because those going to give you the highest profitability index. Now, the risk analysis. Obviously, you have to change. Every time when you go to the bank manager is gonna ask you, how are you dealing with the risk? That means he has to do the sensitivity analysis. One way to deal with the uncertainty and the risk is to do sensitivity analysis. How sensitive you are when the risk going up in terms of how the discount going up that you're choosing, or cash start moving up and down, up and down. How you sensitive on that risk. So basically, we're going to start playing with the situation and we're going to see what's going to happen if the cash goes up, if the cash goes down, if the discount rate changes up, if the discount rate is going down. And you're going to think on which point I can give up the project and which one can continue. So that means that every time when you accept the project, after that, we still have to look for that project. in terms of to compare the actual versus what we were on the budget side. So that is called post-audit of the investment project. So that will be true evaluation of how well the project achieved the targets. Now we start comparing again actual with the budget. And that's going to provide information about how we're doing the budgeting, are we accurate in the budgeting, and what if we have to change something in the future, what exactly to change. Again, we're going to use it as an evaluation technique. And we can use it for the cash payback or the net present value. That's going to help us for future estimates if we have to do new calculations. Let's do this one and see what you can get on this one.
Based on what we just said, sensitivity analysis.
That is correct, sensitivity analysis. So internal rate of return. Finally, we came to the internal rate of return. What's the internal rate of return? The internal rate of return is the simple the return, the rate that brings the net present value to zero. So how much this project actually give you, how much return this project is going to give you. So we can use three methods. First one is to use the financial calculator with the one that you had. Second one is to use the Excel spreadsheet. And the third one is to go with the mistake. Try mistake, try mistake, try mistake, try mistake. Again, our objective is to bring the net present value to zero. So let me show you the three methods and then we're going to do this question. Let's share this one and let me find out where exactly was that one. Not this one. That's crazy calculation here. What I'm chasing is something very, very, very simple. So let's stay with here with this question. Very, very, very first question, if you remember. Let's put those numbers here. And let's see what we get. No, that's not the one. Today, that will be the one. So as we said, the last option is to try with what will be the proper rate. So basically, we start playing with the rate. What if now 12% give us too high? What if we go with the 13? Well, we get into zero. So how much 13 is? 13.2. Well, that's negative. Now let's reduce it then. Let's go with 13.1. Well, still negative. So it's going to be 13.05. Still negative. So that means 13.04. Now it's positive. So which one is going to bring it to zero? 34.5. Now it's negative. So it's going to be 4. Okay, we're getting there. 4.5. No, it's too much. 1.3. Which still too much. 4.2. Okay, we're getting there. And 2.2. And obviously it's going to be 2.3. Too much. 2.21. So that should be opposite. 2, 1. Still too low. 2. There you go. So what's the actual return that we're going to get? Is 13.0442. That's one way to get it. Just simply bring this one to zero. It means that present value that you're going to get from the future payment should be equal to zero. Second option that you have is get this calculation here. Let's flip it on the side and let's start playing with it. So now what we know, what we don't know. I'm going to add a little bit here. We're actually going to change it. First, we chasing here the discount rate, right? That's what we're chasing. We don't know. We try to find what's the discount rate. Now, that will be our internal rate of return. We don't know it. But what we know that net present value is zero. That's what we know. That means that if we remove this one, and we know that the present value, let's go with the salvage value, let's move it up here. And let's go here, the present value, I know the present value, it should be equal to my initial investment, correct? In order this one to be zero.
That's correct.
So that means the present value should be equal to exactly to the cash outflow. So I know the present value. Present value should be $130,000. And that will be my present value. Salvage value in this case was zero. That will be future value. So now what I'm trying to calculate, I'm trying to calculate what's the rate here that I have to get in order net present value to be zero. That's what I'm chasing here now. How much will be this percentage? So let's highlight it in different colors so you can see it. So basically what I'm chasing is a rate. If we go to the formula, sometimes when I'm working with the formulas, I'm forgetting what I have to calculate. So if you go to the present value, which one of those elements we have to calculate? We have to calculate rate, correct?
Yes, that's correct.
So that means we have to find the formula for the rate. So let's go here and see which one says rate. Here, this one is says rate. So if I calculate here returns on the interest rate period on the loan or frequently, and let's go with this one rate, and let's plug in the information. Do we know the number of the periods?
Yes, we do.
10. Payment, we know the payment, negative 24. Present value, do I
Zero.
know the present value now? I want my present value to be 130,000, right?
130, yes.
Right? Future value is zero. So what's my rate of return? So let's flip it. That should be right here. So my rate of return is, let's see exactly how much is it. My rate of return should be this number. So if I use this rate of return in my formula, I should naturally get net present value zero. Is that the case? Yes. So we see how we do it by adjusting, trying mistake until you get it. The second one is just use the Excel calculator and to get it. The third one is the financial calculator, same idea as Excel, just different calculation. So let's see this question now. Let's consider the purchase of the front-end loader with initial investment cost $244,371. Annual net cash inflow are estimated to be $100,000 for the 3 years. What's the internal rate of return? Means at which point this project is going to give us net present value zero. Let's go back to the slide to the Excel spreadsheet and find this question. That should be here somewhere. Question 11. On question 11, what do we have to do? Well, obviously, we have to start applying the formula. Which formula are we going to apply? The formula that's going to bring us to zero. If my initial investment is 244,371, correct? I'm going to get $100,000 over the 3 years. I don't know the interest rate. And I know the future value is zero, no salvage value. Let's calculate the present value. The present value here will be, let's copy the formula. That will be easy as well. I can easily copy this formula. So since I'm not using any percentage, The present value is going to give me simply the cash that I'm going to get over the 3 years. And since every year I'm getting $100,000, that means $300,000. Now the question is, since my outflow, I know exactly how much is it this, what is the point that my net present value is simply zero? Again, we can start with the plugging in the percentage, trial and error approach. Let's go with the 5%. Too much. Too low, 6%. Too low, 7%. Too low, 8%. Too low, 9%. Too low, 11%. Somewhere around 11%. That will be first approach. Second approach, get the information, plug it in the formula. Today we know how much we have to spend. We have to spend 244,371. Payments, we have to make 100,000 payments. We're going to get 100,000 over the 3 years. And the future value is zero. Now we have to calculate the internal rate of return. We're going to use on the formulas for finance, we're going to use the formula called rate. And in the rate, we're going to start plugging the numbers. Periods, 3. Payments, negative 100,000. Present value, positive the amount that we're paying today. Future value, there's no future value, that's zero. So how much is my internal rate of return? Is that much. Now we want to make the calculation to make sure that this is correct. So let's go 244,371. And my annual payment is $100,000. Period 3. Now internal rate of return is equal to that amount. Salvage value is 0. So if I plug those numbers, I should naturally get present value here 0. Sorry, not that one, that's copied. I have to just paste the formula. Did I get net present value 0?
Yes.
By using this percentage. So that means my internal rate of return is 11%. Make sense?
It does.
Okay. We're almost there.
May I ask a question whilst we get
Yes.
there? Between the two different rates that we just looked at and how to calculate it, would we have to choose one against the other versus like internal rate and the other?
They're both the same here.
So
Just the approach that we're taking is different. In the first case, I'm trying to guess what the percentage is, but I'm always going to get the same percentage. This is the method that I can use to guess this one. First, all the 3 approaches, it's going to bring you to the same number, and the number is to bring the net present value to 0. Once the net present value is 0, check what's the rate, and that's your internal rate of return.
it includes the discount rate option as well. So both the discount rate and internal rate option.
And now the discount rate is the rate that you want.
I see.
Right.
So when you're not given the actual rate, you need to work at using.
So you can look at the whole picture this way. Discounted rate simply is the rate that you're using to discount the value of the money and to bring it to the present value. Make sense?
Yes.
Now, what can be the discount rate? Discount rate can be required rate of return or weighted average cost of capital. But it doesn't change the fact that this is the rate that you're using to discount the future payments of cash to bring the present value today. So definition of the discount rate is simply what's the percentage that you're using here in this formula? That's your discounted rate. From where that discounted rate came from, it's a different question. So, or what you're using for discount rate. for discount rate, I can use the required rate of return. Now, if my required rate of return here is 12%, which I'm using as a discount rate, make sense?
Yes.
So where is this project? Well, obviously this project have the net present value positive. Now my next question is, okay, what that means to me? That means you're reaching 12%. Yeah, but am I getting more than 12%? Yes, you are. How much more I'm getting? That's where you're calculating the internal rate of return of this project. So internal rate of return is the rate that this particular project actually give you. Means that net present value is actually zero. Make sense?
Absolutely. Thank you.
That's how you should interpret all the information and everything that we're talking about here. So technically they're interrelated, but by the definition they're different. Okay, let's keep going here. That's one method to calculate the rate by using that try and error method. Then you can go with the capital investment. Then you're going to find the internal rate of return by the formula. Internal investment divided by the block company example, that will be internal rate of return. When we're going and finding some internal rate of return factor, then we comparing that factor in the table and we're getting how much is it. That's another too much. The simple way is use the Excel spreadsheet formula and that will be easy. So once the internal rate is determined, the question is the internal rate of return equal to what we want? Internal rate of return, again, is associated only and only with that particular project. And then we compare it. If that particular project give me 11%, how much I want? If I wanted 12%, that rate is not there. If I wanted 10%, yes, that project is acceptable, right? So the last one is the comparison between the internal rate return and the net present value. What's the differences, or how can we interpret those two? Net present value simply calculate a number, which number later on using is this project reach the rate of return that I want or not? Where the internal rate of return is the actual percentage that project give you in order to reach net present value zero. That's how you should interpret the numbers. Minimum expected rate of return, how are we going to call it also?
Hurdle rate.
Hurdle rate is also hurdle rate. Yes, that's correct. And if we have to do this question together, let's go to the Excel spreadsheet one more time. And that will be question 12. If we have this one, so the industry consider purchasing a new equipment that initial cost is 426,455. That's the present value. Now the expected useful life is 5 years. And they're going to generate 98,500 each year. Is there any salvage value? There's no salvage value. So what is their discount rate? That's what we try to find out here. So basically, we're going to go to the financials. We're going to use again the rate formula. And we're going to get for the rate N is our 5. Payment is negative 98,500. Present value will be that much, and the salvage value, which is future value, we're going to get nothing. So our rate is, this project going to give us 5%. The rationality here is if today we spend 246,455, and we're getting payments of 98,500, and the periods is 5, and my internal rate of return is equal to my discounted rate is equal to the internal rate of return which I just calculated. The question is my present value be equal to 0? That's what I'm chasing here. And copy this and paste it here. And obviously my present value is 0. Net present value is 0. This is another way you to check yourself. Is this number actually make sense? It does make sense because the net present value is 0. So what's the return that you're going to get on this project? Only 5%.
5%.
If the interest requires 7%, would you accept this project? Obviously not, right? The last one is the annual rate of return method. Annual rate of return method is then we're going to get the expected annual net income divided by the average investment. This method is too much. So I'm not going to test you on this method. So what we're going to do here is we're going to get the average investment, which is the beginning of the investment and the salvage value of the investment, the beginning and the ending, divided by 2. That will be the average investment. Then we're going to check the accounting income. And once we get the accounting income divided by the average investment, then you're going to get some percentage. Now the question is, how accurate is this percentage? Is that acceptable or not acceptable? Now, how accurate is simple to calculate, and the management is more likely to be familiar with the accounting information, which is now is questionable. So the against this method is it doesn't consider again time value of the money and can manipulate the accounting data so you can get whatever I want you to get, not what actually is. So the annual rate of return method is based on which one of those? Obviously, it's not time value of the money. It's not cash flow data. Definitely not the market value, so it left
Accounting data.
accounting data. And that concludes this chapter.